All right, we're going to take a look at 2.2, reading a graph. So I have provided a graph for you to make it easier to refer to as we go through all the aspects of this graph. And we're going to be taking a look at vocabulary. Today's very heavy on making sure you understand the academic language as we're describing this picture. So what we looked at the other day was we looked at things like a function, domain, range. So just to recall a little bit. The domain are the x values of a graph or of a relation. So we're going to go back through this in just a minute. So we're talking about the x-axis. So it's always important to label the x-axis. And as we read from left to right, always reading from left to right, that's our domain. Our range is the set of y values. So when we're talking about the range, again, we need to order them, and we always go small to large. So the range is going to be starting from the negatives and going up to the positives. And then a function, of course, is a very important relationship between the domain and the range. And it says for every x value, there can only be one y value. And I may have used different wording the other day, but it's the same idea. For every x, there's only one y. Okay? And so we talked about a tool that you may have learned in algebra. Pencil test is a tool, vertical line test. For each x value, it can only touch the graph at one time to be called a function. So as I move this vertical line, because x equals a vertical line, every time that x value intersects the graph, for it to be called a function, it can only have one point on the graph. All right? So we talked about function notation, and we talked about when you have function notation like f of x or g of x, this is exactly the same as your input is whatever your x value is, and your answer is whatever your y value is. So f of x is the same as saying your y value. So at the top of the graph, which you may not be able to see, I labeled it the y-axis. I could have called it actually f of x. So instead of y from now on, you could write that as f of x. You can write it as f of x if the graph you have is a function. Let me make that a little clearer for you. Okay? So if this is a function, I can call it f of x. All right, so we're ready to go. Now, mathematically, simply use the definitions. So we're going to start looking at some questions. And if you've got these printed out already, that might make it go a little quicker, but I did include the sketch. So we're going to take a look at the graph of this and ask ourselves, first of all, this is a function because we already said for every x value, there's one y value. And so that's why I called it f of x. So here's my first question for you. Okay, I'm going to tell you that the point 2, -4 is on the graph. So what does that mean? Well, what that means is that's exactly the same as saying f of what is what? Well, we just kind of went over that. That's the same as saying, well, we know what our x value is. Our x value is 2. That must mean when x is 2, our y value is -4. So if I go to my graph and I go to where x is 2, you'll notice f of x, or the y value, is negative 4. So if I'm just going to ask a few, and I'm not going to do all of them because you have the picture with you, but if I go through, and let's take a look at f of 0, f of 7, f of negative 6, and just practice a couple of them. F of negative 5. Let's start with that. Okay. So analyzing the graph, we've given you the x value, we've given you the domain value, we've given you the input value. So if I input 0 into the graph, when x is 0, what is y? Well, when, okay, where is x 0? X is 0 here. What is the y value? Negative 2. So this would be the point 0, negative 2. Where, okay, let's keep going. If the input is 7, positive 7 is right here. Our output is, according to our graph, our output is negative 3. So that's the same as the point 0, 2. That's the same as the point 7, negative 3. It is not necessary to write it as the point. I'm just trying to demonstrate that it's the same thing. So academically, this says it's a function. So at negative 6, I know I should only get one value. And at negative 6, we get 0. You do not have to write the point, just helping. And at negative 5, we end up with negative 2. Okay. So we're just saying, okay, for this particular function, those are points on the graph. Now, I'm going to ask you the following. Is f of 1 positive or negative? So f of 1, this represents a point. So find the point f of 1. When x is 1, what's the y value? Positive or negative? Well, because the y value is below the x-axis, f of 1 would be negative because here's 1. So f of 1 is down here somewhere on that graph in the negatives. So what about f of negative 2? So again, look at negative 2. When x is negative 2, our y value also happens to be negative. So this section is about learning to interpret a graph so that we know the proper way of reading the graph. Because it is a visual representation of a lot of data. So let's take a look at another one. Now that we understand how to read the points, don't change anything. Okay? So what is the x value given f of x equals 3? So we need to look at what I've actually asked you for. What have I given you and what have I asked you for? We know f of x is exactly the same as the y value. This time, I don't know what x is, but I know the y value is 3. So the question is, find all the x values that give you a y value of 3. So if I go up here I have a ruler, that'll be nice. If I go up here and I go up to where 1, 2, 3, the y value is 3, well, it appears as though we have 2 points that have a y value of 3. Okay? So those 2 points that have a y value of 3 appear to be -8 when y is 3, +5 when y is 3. So I end up with 2 different values. Always go in order from small to large because we always read from left to right. We always list things from least to greatest. Okay? So let me write a couple more down. Part I. Same type of question. What is x? Okay. What is x if f of x is -5? What is x if f of x is 0? So it's analyzing the graph. Look at what I've given you. This time, instead of giving you the x value, I've given you the y value. So when y is -5, and if it helps you, write down what you know this is exactly the same as the point. I don't know the input, but I know the output's -5. So if I go down here to where the y values, y equals is a horizontal line, 2, 3, 4, 5. Once again, it looks like I may have 2 points on the graph, -4, -5, 8, -5. X would be -4 or 8. And if f of x equals 0, that's exactly the same as asking you what are the x values when the y value is 0. We know that's also called an x-intercept because the y value is 0. And so it looks like we have 1, 2, 3 places where the y value is 0, -6, 4, and 6. And now we need to start interpreting multiple types and sets of answers. Okay. Same type of idea. For what values of x is f of x greater than 0? What values of x is f of x greater than 0? And this is where we're going to get infinite sets of answers because we need to analyze. This is asking you, what is x when y is greater than 0? All right. Well, y is greater than 0. We know the y values are the ones going vertically. Y greater than 0 implies I want everything above the line y equals 0. So I need a way to describe all these infinite points that are above 0 for y. So this is where our intervals come in. Intervals. I need to know the value of x. So that must mean, as I read left to right, I need a way to represent this x value, 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 this one, this one, this one. I need a way to represent every single tiny molecule where the y values are above 0. Well, as I read from left to right, the graph is not out here. So it looks like the very first point I'm going to start with is when x is -8. Since it's a solid point, that must mean it includes -8. I want all the x values. Notice I'm moving the pen across. as the y values stay positive. So I'm going to write the word first. I need the interval because I need movement. I need this entire starting to stopping point. Okay? If I use algebra, I would have said everything between -8 and let's see, what's that other x value? It looks like, if I move looks like everything is positive until I get to where x is -6. So this is how we would have written it in algebra, but we're not in algebra anymore. So since we're in pre-calculus, we can use an interval. So the better way to write this would be close bracket, because it's less than or equal. Our lower bound, our smaller numbers, start at -8, end at -6. And because it includes -6, we would do a hard bracket. Okay, so we always look at that interval. It's reading from left to right, every single x value. So let's try it again. Oh wait, there's another one. I forgot the other interval. Because that describes this set of numbers. But remember, we have this little peak over here. So we need to also describe all of these positive numbers. So as I'm reading from left to right, I just need to know where does it start and where does it stop. So the other interval, I'll use algebra first. In algebra, we would have said 1, 2, 3. This is the point 40. This is the point 60. And notice the graph is above where all the y values are positive between them. So in algebra, we would have said, okay, start at 4. All the x's are trapped between 4 and 6. But in pre-calculus, we can write the interval as starting and including the number 4, stopping and including the number 6. Okay. And let's finish out before I need to erase. HIJKL, same type of question. What values of x is this function, f of x, less than 0? So this time, I want all the parts of the graph where the y values are less than 0. So I want all the negative values for y. Well, as I read from left to right, y is positive, 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 stop. I hit 0. But now look at the y values. They're all down here in the negatives. Negative, 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 negative. All these y values are still negative until I get back up here to 0. So this entire interval, I need to change this. I made a slight error, but I'll come back in a moment. Okay? Where is this entire interval negative? Well, it's negative between, now remember these are intervals. It starts at -6, that's why I need to go back. But it doesn't say it equals 0, therefore I can't equal that point. So it's like an open circle. And it goes between -6 and 4. And then at 4, it hits 0 again, so we cannot include 4. So that's what I need to go, and I'll finish this one and then we'll go back. And there's another interval that is also negative. It looks like it starts again at 6, and all the y values are negative until we get to 8. So I can't include this point because y is 0. Here it says just less than 0. But I can include this endpoint because this last value, okay, is a point that's negative, so I can touch that point. So the little error I made was on the previous one when I asked you where is f of x positive. I made just a slight little error. -8, 3 is positive, but 0 is not. 0 is neither positive nor negative, so I cannot include the -6. So this would need to be an open circle, so it needs to be an open bracket. And similarly with both of these points, they actually don't equal 0. 0 is not negative or positive. Therefore, this would need to be strictly less than. Therefore, both of these cannot touch those intercepts. So it should be open bracket. All right, let me make a little more space. I'm going to use the same picture. Okay, and let's clear some of this out because we're talking about intervals. So a graph can really help represent data, increasing, decreasing, highest point, lowest point. All right, I think I left off with ill. I have a few more. But instead of having to graph several different pictures, I thought it was easier to give you one picture with several answers and questions. I just switched colors on you. What is the domain? Well, we know the domain is all the x values. So what we need to do is, as you read from left to right, we need to think about the very first place where you have a point on your graph. Well, the very first value where you have a point on your graph is when x is here at -8. And then as I move across, there's a point at every one of these little molecules. And so this domain, all my x's keep going until I get to the very last x where I pick up my pen at +8. So this domain goes between, and I'll write this two different ways, -8, including that point because it's solid, +8, including that point because it's solid. There's no holes in the graph. So in algebra, we would have written it this way. -8 is less than and equal, because it's a solid point, all the x values, and they went all the way to +8. As an interval, which is the preferable way of expressing this, it went from -8 to +8. Since we touched both points, we make it a solid bracket. Let's do the same for the range. Okay, well the range we know are the y values. All right, so if I take a look at the y values, again, I go from small to large. The y values, the smallest graph way down here at -infinity, not there. The smallest y value that shows up on the graph looks like it happens to be -5. And then all we need to know is, as I'm going up my graph, what's the highest possible value? and it looks like the highest possible value, including every point in between, happens to be 3. And sure, we have all of this, but all of these y values are also included if I go between -5 and +3. So in algebra, we would have written -5 is the smallest y value. It's less than every other y value, and it's bounded by the largest y value of +3. So as an interval, which is much better to write as an interval, we would have said start at -5, end at +3. Okay, the next ones go pretty quickly. LMNO. Okay, what are x-intercepts? Or maybe there's only one. What are the y-intercepts? Maybe there's only one. Well, we already know what x-intercepts are. Okay, last chapter, I had you always write down set x equal to, or if it's an x-intercept, we already know we're supposed to set the y value equal to 0. So I'm going to do that. Okay, all the y values are 0. So if I look at my graph, I need to know what all the x values that give me a y value of 0. So as I read from left to right, the first x-intercept is -6, 0, 4, 0, 6, 0. So I write them in order from left to right. 6, 0, 4, 0, 6, 0. Okay, so I can have multiple x-intercepts because the graph moves from left to right. Y-intercepts, we know how to find a y-intercept. If you followed directions last chapter, it said start off by setting x equals to 0. Okay. So I know x is 0. We want to find all the y values where the x value is already 0. Well, so let's see. If I go to where x is 0, there's only one y-intercept, 0, -2. In fact, there can only be one y-intercept. Because this is a function, at that x value, I'm only allowed 1 point. So if I had a second y-intercept, it wouldn't be a function. 3 more questions. Okay. How often does the graph of x equals 3 intersect the graph of f equals x? How often does x equal 3 intersect the graph of f of x? So let's interpret what this question is asking. Let's annotate what this question is asking. How often does x equal 3? Well, we know what x equals 3 is. X equals 3 is a line. So this is a vertical line. So we need to remember our prior knowledge about lines from chapter 1. All right, so that's a vertical line. Let's think of it this way. Every time I go to x equals 3. So if I take this vertical line and I go right here to x equals 3, how many times does it intersect the graph? Well, it only better be once. It better be once because this is a function. So when x is 3, it's only allowed to intersect at 1 point. Whatever this point happens to be right here. I have no idea. It doesn't matter, but that's where x equals 3. So it only intersects 1 time. Otherwise, it wouldn't be a function. How often does the line y equal -2 intersect the same function. Well, again, this goes back to prior knowledge of what y equal -2 means. Y equals -2 is a line. Y equals -2, we know, is a horizontal line. So where if I analyze this and I go to where y is -2, there's a whole bunch of places where y is -2. So if I go to where y is -2, sure looks like it intersects this graph at multiple locations. Notice that I didn't ask you what are the points of intersection. I just asked you how often. So I'm looking and having you analyze. So how often does that horizontal line at -2 touch the function that we have? Well, it looks like there's 1, 2, 3, 4, 5 times. Okay. We're almost out of the alphabet, so we got to be getting close. How often does y equal x intersect this function? I like this question because now we have to know what y equals x is. We have to know that that's this identity function. We have to know what that graph looks like. Well, based on Algebra 1, based on Algebra 2, based on geometry, based on last chapter, this is a line with slope of 1 and a y-intercept of 0, 0. mx plus b. So, all right, if I think about sketching that line, and I actually will go through and sketch that line. I don't have graph paper, we can sketch it. Y equals x, so x equals y. So that would be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Okay, and I sketch this line. Well, it looks as though if I sketch this line, there's a rough sketch of the line. It looks like that line of y equals x only intersects at one point. That point I gave you earlier is -1, -1. So it looks like it only intersects once. Okay, so this particular section is all about reading and using the academic language that we've gone over and you've used in algebra. So now you get to apply it to a picture. So what I did print out for you, if you take a look, here's one example. There is a second example. If you print this out from Canvas today, there is a second example on the back that you can look at and practice reading your graphs as well. Right? All right, so that's how we can read a graph. Our next section, we're going to go a little bit more into reading graphs. So I will see you next time.